Now only live.
Okay.
Hello, everybody. This is Aziz Yasri from Morocco, from University Mohammed VI, Polytechnic in Morocco. So I'm really delighted to welcome Professor Hakim BOULAL from the African Plant Nutrition Institute and for his webinar. But before, I really would like to thank you for the massive participation to this webinar. So before, again, to start this webinar, I would like to ask Professor Hakim BOULAL to introduce us to the African Plant Nutrition Institute, that we can have a good idea about this institute, since Professor Hakim BOULAL is the second speaker from this institute. Please, Professor Hakim BOULAL, if you can introduce us a little bit about what is African Plant Nutrition Institute, what's its mission, objectives, and what kind of research and activities are being conducted in this institute.
Thank you very much, Professor Yasri, for the invitation for this webinar, for the ESAFE and for EMCSP and the OCP for hosting this webinar. Yes, I am the second participant in this webinar after Dr. Abouzou. About African Plant Nutrition Institute, it is a new institution created since 1 year, based in Morocco, but it is a continuation of a previous institution, is IPNI, International Plant Nutrition Institute, because most of the scientists now working in APNI are from this previous institution. We are now based in Bendir, in UMCSP, where is our headquarters, and we have 3 regional offices, one in for North Africa based in Satat, another one in Yamoussoukro in Ivory Coast, and the third one for East and South Africa based in Nairobi. We are a multinational scientist. The objective for African Plant Nutrition Institute is the promotion and the dissemination of best nutrient management practices, drought research and development in collaboration with the national institution and also international organization. We have, since 1 year, we have started our program, established several programs in various regions of Africa. In North Africa, the main crop where we are working now are mainly cereals, olive, citrus, and date palm. And our objective is the promotion of the best nutrient management for this crop based on the 4R nutrient stewardship. We have also included this year Mauritania, because we have started with the program of wheat, and next year we will continue with rice program in Mauritania in collaboration with the National Research Institution there. We have other group working with us in this different region for maize, for example, in East and West Africa, and also other program of collaboration. All our research is established and under collaboration program and project with national and international organization, which is one of them is UMCSP of Mohammed VI Polytechnic in Belgrade. Thank you.
Thank you, Professor Hakim, for this introduction. So I'm just sort of summarizing what has been said about the African Plant Nutrition Institute. So just for the people who are just joined us now, we have started the webinar by Professor Hakim BOULAL from the APNI, and Professor Hakim BOULAL just gave us an overview about the African Plant Nutrition Institute, which is based in Morocco, and he said that this institute is a continuation of the previous institute, which was the International Plant Nutrition Institute, which becomes now, since a few months, I think, the African Plant Nutrition Institute. Professor Hakim BOULAL is part of this organization, and he really stated the importance of this institute in conducting research activities in plant nutrition in general, focused on some key topics in agriculture and plant nutrition related issues. So if you have just joined us again, I am really delighted to host Professor Hakim BOULAL from African Plant Nutrition, and Professor Hakim BOULAL is our second speaker from African Plant Nutrition Institute. We had the pleasure to host professor from the same organization last week, Professor Koko Amenzu. Today, Professor Hakim BOULAL will talk about tailoring nutrition management for conservation agriculture in Africa. So before handing the floor to Professor Hakim BOULAL, I would like to give you a short introduction about him. So Dr. Hakim BOULAL got his PhD in biology and agronomy from the National School of Agronomy of Rennes in France, and the second PhD from the University of Cordoba in Spain on conservation agriculture, including soil and water conservation, crop management, and irrigation management, which is somehow the topic of today. So Dr. BOULAL has over 25 years of experience in applied agronomic research and rural development. He began his professional career in Morocco within the National Institute of Agronomic and Research, INRA, by leading a regional research development unit of INRA in central Morocco. His research focused on cropping systems, water use efficiency, and soil and water conservation. Dr. BOULAL has authored and co-authored numerous books, referred journals, chapters of books, manual guides in his expertise areas on annual crop production, crop ecophysiology, conservation agriculture, nutrition management, soil and water conservation. So Dr. BOULAL started his international career with the International Center of Agricultural Research in Dry Areas, ICARDA, where he coordinated research projects in Morocco on improved water management for sustainable agriculture and provided direct support to national institutions. So prior to joining his actual organization, African Plant Nutrition Institute, Dr. BOULAL was deputy director of the International Plant Nutrition Institute, North Africa program. As program manager of APNI, North Africa, Dr. BOULAL's responsibilities include the management and leading of projects with national and international institutions, fertilizers companies, and other organizations in the region to research, development, and capacity building program for improving knowledge on the best nutrient management practices in Morocco, Algeria, Tunisia, Mauritania, and Senegal. Again, it is really a chance for us today to have Professor Hakim BOULAL from APNI, that with his really huge background in plant nutrition and plant nutrition management. So Professor BOULAL, please, the floor is yours. So if you can elaborate on this topic, so about 40 minutes, and we will follow this your talk by some question and answer from the audience. Please go ahead, Professor Boulal.
Thank you very much, Professor Yasri, for your presentation. Thank you for all the participants in this webinar. And as you said, today is the day of conservation agriculture in Africa. I would like to present the nutrient management of conservation agriculture in Africa, draw all the concepts related to conservation agriculture. First of all, conservation agriculture.
Could you please make it whole screen? That's good. Thank you.
Yeah. Okay. It was a concept to land management that seeks to optimize crop yield and farm profit without environmental benefits. The principles for conservation agriculture are based on that intensive tillage is not being necessary because it leads to land degradation and soil erosion. FAO defined 3 pillars for conservation agriculture. That conservation agriculture can be implemented or associated with no-till or reduced tillage, permanent soil cover by crop residue or crop rotation. If we consider no-till system, we need adequate equipment for direct tilling because we don't more till the soil with the introduction of conservation tillage. Why? Conservation agriculture allow direct planting without tilling the soil in the objective to, first of all, protect soil organic matter, improving soil aggregate for the stability of the soil, improving water infiltration, and in consequence, we decrease also the soil erosion. The second pillar for conservation agriculture is to maintain in the soil a permanent soil cover, drought, a cover crop, or drought residue. At least, according to the FAO definition, at least 30% of residue should be retained under conservation agriculture. The objective for maintaining soil cover, even between growing crop as intercropping or after cropping season, like residue after harvest, the benefit is that these residue constitute a source of organic matter for plant nutrients. Also, the objective also to maintain this permanent cover is to protect soil against erosion for increasing also water infiltration, improving soil biological activity, and also reduction of compaction by machinery. You know that if we maintain a certain amount of residue, the 1 pass or 2 pass by the machine can induce some compaction. Why? The role also, if we have heavy residue, we can reduce also the effect of compaction. Also, with the shadow of the permanent cover, we can reduce the population of weed. Some studies have demonstrated in smallholding farmer in Africa that 3 tons of humus per hectare are necessary to cover the soil. The crop rotation is introduced as the third pillar for conservation agriculture. The role of crop rotation is to overcome the pests and disease, also to increase the soil fertility, and to contribute in diversifying farmer income. because the farmer, and mainly the smallholder farmers in Africa, they should to diversify their income because, you know, a high variability also of climate, and also the high variability between one region from another. That means that we need, all the farmer need to diversify their production. If we adopt this three pillar, the benefit of conservation agriculture is to control soil erosion, because a lot of land in Africa are degraded. Also, another objective to reduce water runoff, because we need to collect the water loss in sloping area or degraded area, and increasing water infiltration. Second objective, according to that, we can improve soil quality by maintaining residue, by maintaining cover crop, or by respecting also the crop rotation. And one of the third benefit also is the reduction of cost of land preparation. You know that with this system, the cost of land preparation is higher because the preparation of the soil need several passes. However, in the case of no-tillage system, just one pass at planting time is needed. Also, with conservation agriculture or no-tillage system, we require less rainfall for planting at optimal time, because in tillage system, the farmer need to wait the first rain before to planting. However, no-tillage give for the farmers the opportunity to plant with less rainfall compared to conventional tillage. Also, the third advantage is with heavy residue, we can reduce the population of weeds under conservation agriculture. The benefits of conservation agriculture and yield require continuous year of application, because you know that the effect of conservation agriculture is not in short term, because in the first year of adoption of or introduction of conservation agriculture, the soil quality is improved. Also, some characteristic also the soil, but the yield come after that. We can maintain the yield, but the improving the yield versus the conventional tillage need more time. Why the advantage of conservation agriculture and yield appear at long term instead of short term. Also, another benefit of conservation is on climate change mitigation, because one of the reasons for the apparition also or the adoption of conservation agriculture was that conservation agriculture has been considered as smart agriculture, aimed to enhancing climate change resilience for smallholder farmers across Africa. And conservation agriculture has the potential to reduce gas emission by reducing machine passes in land preparation, and also by increasing the carbon sequestration. Switching from conventional tillage to conservation agriculture has been demonstrated that has a large potential for carbon sequestration in Africa. The table presented by Gonzalez Sanchez and collaborators showed that in Africa, the carbon sequestration is around 1 ton per hectare per year. Even we have some variability from one region to another. For example, if we look to the annual crop in Mediterranean area, we have 0.4 ton per hectare per year of sequestration of carbon, and we can go until equatorial area until 1.5. The applicability of conservation agriculture over the world is large. Until now, conservation agriculture is applied over all the continents, and it is applied in large type of soils, from heavy clay can be until sandy soil. Also, it is applied for a wide range of species like wheat, maize, some legumes, crops, rice, and industrial crops. However, conservation agriculture has some limitation in waterlogged situation, also soil that are too sandy, very high sand, and also in very cool climate. In Africa, conservation agriculture until now is applied in most regions of Africa, from semi-arid to favorable rainfall. For example, in the case of North Africa, for that, in North Africa, conservation agriculture is now in the three countries, Morocco, Algeria, and Tunisia. Also, it is applied now in mid and Saharian area of Sub-Sahara Africa. And since the 80s, conservation agriculture has become a major part of the research agenda in Africa. Until now, at least 17 African countries are assessing or using conservation in agriculture in Africa, from the North African in the north to South Africa. However, conservation agriculture compared to other countries and other continents still less adopted. Africa accounts only less than 1% of the world total conservation agriculture area, with 98% practiced in the southern part of Africa. What is the most constraint for the adoption of conservation agriculture in Africa? We have the most important constraint, because in Africa, in all Africa, farmers, they adopt an integration system between the cropping system and livestock. For that, the competition for crop residue is for other needs like feeding livestock, or because in some area of Africa, residue are used for construction or also for fuel for cooking, for example. Also, conservation agriculture, mainly in the initial year, is more dependent on the application of herbicide to kill the weeds. One also of the most constraints here, because one of the objectives of the farmer is to increase their livelihood, drought, improvement of grain yield. However, because farmers are looking for immediate yield, the benefit from conservation agriculture to be adopted by farmers still low, because the improvement of yield under conservation agriculture is at long term instead of short term. Also, we have a lack of profitable adaptation of rotation system and the lack of suitable drill machine adopted for conservation agriculture and for direct drill machine. In addition to technical constraint, we have socio-economic constraint for adoption of conservation agriculture in Africa. Conservation agriculture in Africa is not yet well integrated in the government policy and the agenda. Also, we have the lack of subsidized and efficient incentive in a context, because large farmers in Africa are poor. The land tenure, also the system of the land based on hiring land or only using rights of cultivation, because of conservation agriculture need permanent, is one of the contracts also to adopt conservation agriculture. Also less access and knowledge on conservation agriculture, and also a lack of functional output market for rotational crops, because the introduction of new crop in crop rotation under conservation agriculture need a market. Also, because the weeding system under conservation agriculture, greater working there is need for women, because women are working more than men in the field in Africa. But why conservation agriculture can benefit in Africa? Because low fertility of majority of soil in Africa due continuous cultivation with minimal, low or no external nutrient input in land degradation. Also, we have a loss of fertile top, drought erosion, and also because large areas are semi-arid with high soil evaporation, like, for example, in North Africa or in the Sahel region. In consequence, the successful implementation of conservation agriculture needs special nutrient management strategy. We need a balanced nutrient supply. We need also adequate crop nutrition that can be provided by various sources like mineral fertilizer, compost, or manure. The current nutrient management by smallholder farmer in Africa is unable to access to mineral fertilizer due to the lack of credit, fertilizer high cost, and general lack of policy and institutional support for fertilizer use. Therefore, farmers manage their cropping system at low input with low use of fertilizer, mineral fertilizer, and also organic fertilizer. The constraint of fertilizer use in Africa is the dominance of smallholder farmer with low income. Also, because fertilizer, sometimes they are not available at the right time. Also, the little fertilizer available is often not the correct type required for various crops. In general, fertilizer recommendation in Africa are done at district level without taking into account and the site-specific characteristic, and also the lack of appropriate soil fertility map in a large part of Africa. Even without that, in some country, soil fertility map is developed. For that, we need to overcome the negative nutrient balance in small farming system in Africa. The continuous soil fertility depletion in many farmer systems in Africa has led to an alternative approach for nutrient management based on increasing the input of nutrients from biological nitrogen fixation, organic material, and also mineral fertilizer, and also adjusting the rate of nutrients added to the storage capacity of the soil, and efficient use of nutrients with limited amounts of mineral and organic fertilizer. And actually, the investment in agriculture is become a priority for African governments. Numerous African governments responded to the perception of low inorganic fertilizer use throughout a commitment to reinvest in agriculture. Why? Africa Fertilizer Summit Declaration of Abuja in 2006 called for an increase in inorganic fertilizer use by smallholder farmers in Africa. For optimizing nutrient management in Africa, we need the use of sufficient nutrient supply to generate enough biomass in conservation agriculture system and to overcome nutrient deficiency. We need to fertilize the soil rather than the crop, which is feed the soil and let the soil feed the plant. The aims of best nutrient management in conservation and Africa is to improving and maintaining biological process of the soil, maintaining sufficient nutrient stock in the soil, meet also the crop need, and stabilizing and or improving the crop yield. We are moving in the future from sick to healthy soil, which is the role of conservation agriculture. We are switching from conventional tillage to conservation agriculture system, which need for positive result 5 to 20 years. For that, we need to evolving nutrient management practice that respond to a changing nutrient needs of the soil and cropping system. Keeping healthy soil is the key for a best nutrient management strategy under conservation agriculture in Africa. Why keeping healthy soil in Africa? Because healthy soil can produce better yield, what need the farmers. But how can conservation agriculture make a soil health? By maintaining crop residue and soil surface and avoid to be grassed by animal. Adding also organic matter and plant nutrition, such compost, manure, mulch, and inorganic fertilizer also. Maintaining plant cover to protect the soil and produce more organic matter. The benefit of conservation agriculture and soil health need time. In the initial 5 years, we observe slight change in soil organic carbon, mainly in the topsoil, and also we look at the rebuilding of the aggregate. From the 5 to 10 years, soil organic will continue to increase, improving soil structure with benefit effect and water infiltration, because the aggregate are more stable. From 10 to 20 years, improving also, we are improving drought conservation agriculture, the fauna activity, and also the soil organic carbon is increasing. And after 20 years, the maximum benefits can be achieved if the three pillars of conservation agriculture are respected. Over time, practices of conservation agriculture contribute in balanced nutrient in the soil, because with intensive tillage, the soil organic matter is reduced, also the soil porosity and biological activity. However, switching to conservation agriculture will improve, facilitate the formation and the existence of a nutrient balance. And at long term, the adoption of conservation agriculture practice can lead to higher build-up of nutrients in the topsoil. The example here is from Africa, exactly from Zambia, where the conservation agriculture can increase the biological activity. If we can see in this figure, we see the huge difference between the number of earthworm in the soil between conventional tillage and no-tillage system. Also, the effect of conservation on soil propriety. By adopting conservation agriculture, like this example from Zimbabwe, we can increase significantly the soil organic carbon, but also we reduce the bulk density and we increase the pore volume, which has a positive effect on water infiltration. The sustainability of conservation agriculture for farming system in Africa require adequate nutrient supply that can be achieved without mineral fertilizer, integration of legume manure or compost. Smallholder farmers in Africa often lack the capacity to buy sufficient amount of mineral and are therefore more dependent on alternative resource and diversification strategy. The appropriate and efficient use of mineral fertilizer is a key issue for enhancing also the success of conservation agriculture. Mineral fertilization in Africa has been promoted for decades, but its use has remained very low in Africa. The average smallholder in Africa for the use of fertilizer is less than 20 kilo per hectare. In North Africa is less than 50 kilo per hectare. Most research in Africa showed that nitrogen and phosphorus were the common nutrient limiting crop, but there is growing evidence that other nutrients, such as potassium, sulfur, and other, can also affect the production. The components of conservation and nutrients management, as we have cited, the three pillars of conservation agriculture has a significant impact on nutrient distribution and transformation in the soil. The altered nutrient availability may be due to surface placement of crop residue in comparison with the incorporation of crop residue with tillage. The conservation agriculture practices increase the availability of nutrients near the soil surface where crop roots proliferate or also where crop residue are maintained. The use of fertilizer is not only to increase the grain yield, but also to increase the quantity of crop residue, because as a pillar of conservation agriculture, the maintenance of a certain amount of crop residue is necessary. For that, balanced fertilizer application can substantially increase grain yield, but also the available biomass in different agroecological regions of Africa. Positive response to fertilizer has been observed in many cultivated crops, and while appropriate fertilizer use has subsequently been identified as a key for enhancing crop residue and the production of sufficient crop residue to ensure soil cover under smallholder conservation agriculture system. The example here is for now Africa, where conservation agriculture research started in the late of 18, and now actually more than 20,000 hectares are planted in, under no-tillage system in North Africa, and with long term, more than 8-9 years, we have seen a positive effect of conservation agriculture and grain yield compared to the conventional tillage. The adoption of conservation agriculture is not only increase the yield of grain yield at long term, but also which is important. The first step is the soil fertility. The adoption of concept at long term generally increase nitrogen, phosphorus, potassium in the surface compared to conventional. However, the effect of concept on soil fertility is also site-specific. Why? Site-specific nutrient management is very important in North Africa, and it depends on the soil type, the cropping system, and other agronomic management. For example, for nitrogen management, under nutrient limited condition, good fertilization, especially with nitrogen, is essential for conservation and to improve crop yield and to produce sufficient crop residue for surface mulching. Also, during the first few years of conservation agriculture, nitrogen is often found in organic form, but not readily available to plant, where the application of nitrogen in mineral form is recommended. The application of nitrogen-based fertilizer is often recommended to increase soil organic, particularly on land with low soil organic matter. As this you can see in this example, where the application of nitrogen fertilizer can increase the soil organic matter in South Africa. The phosphorus management is another nutrient important under conservation agriculture. As we know, phosphorus is not biologically fixed, but phosphorus content of plant residue and manure is normally sufficient to meet the requirements of sustainable crop production. Despite its promotion and adoption in area with phosphorus deficient soil, conservation has not been considered for its potential to improve soil phosphorus, at least at short term. However, results from North Africa showed that the adoption of no-tillage system increase the extractable phosphorus in the top soil. Why? Improving access also to phosphorus can help farmers to improve benefit, mainly for the case of legume. The application of phosphorus in many research have demonstrated that phosphorus can improve legume production and also legume residue in Sub-Sahara, also and in North Africa. For the case of potassium, the decomposition of crop at the soil surface slowly release potassium in the surface soil, and crop develop superficial root that absorb nutrients and mobilize them within the profile. One, the application of banded potassium flush should be applied below or to the side of the seed row, which is one of the best placement for best nutrient management in potassium. but adapting nutrient application to no-till system need a specific material and a specific placement. Why now large number of African countries are developing specific tools for the implementation and for the plantation. Manual tools have been developed, but also specific drill machine in several regions of Africa. But in Africa also other nutrients can be required for the production of annual crops, although nitrogen and phosphorus, other nutrients such potassium, sulfur, and calcium also. Nutrient management for conservation agriculture in Africa is not just fertilizer, but also the management of cropping system, because the cropping system also contributes to best nutrient management in Africa. Under conservation agriculture system, nutrient must be management with crop or mixed crop, which is called intercropping also. We have the crop rotation, but we have also the intercropping. Crop rotation will become important considering the market potential, as I have mentioned before. We have the potentiality here in Africa for oilseed crop, for grain, and also for forage, legume, and cereal. In the management of legume crops, either as previous crops in the rotation or as components in a cover crop before the next cash crop, the application of nitrogen can be replaced by the nitrogen captured by the legume. Why the legume is one of the important crop in intercropping and also in crop rotation in conservation agriculture. In many farming systems in Africa, the inclusion of legume in the cropping system change the dynamic and the pattern of the nutrient. Why the integration of legumes in intercropping or in rotation results in positive improvement in subsequent or in inter-cereal crop due to legume nitrogen fixation. Specific nitrogen fixation are in this type show that with diversification of legume, the nitrogen fixation can go from 3 kilo, for example, per hectare in some crops to more than 200 kilo per hectare per year, which show the importance of legume in the cropping system under conservation agriculture for fixing nitrogen. Also, the comparison between cropping rotation, also the tillage system, showed that when we go from a monocrop system like continuous maize, for example, to a rotation system like, for example, the soybean maize intercropping, we improve the soil organic carbon, but also the total nitrogen. The comparison between the tillage system show that no tillage improve the soil organic carbon and total nitrogen in the cropping system. However, some constraints exist for the adoption of legume under conservation agriculture system. The capacity of including legume to improve nutrient may become a key issue for its adoption. Why? Because this benefits the adoption for soil fertility enhancement, also in rather the plant most offer some direct benefits. But example from some region of Africa showed that legume has some constraints for adoption. For example, here from South Africa, a diagnostic study showed that just old and poor farmer adopted legumes, but also the integration become not attractive for them, because they are looking first of all for some crops for human food, but also for animal fodders. In addition of the intercropping and crop rotation, organic material can be a possible alternative for complementing the chemical fertilizer for smallholder farming. Organic, for example, manure is a traditional amendment often used in combination with mineral in smallholder farming system in Africa. The organic material can be a relatively important source of nutrient input for many African smallholder farmers. The management using organic nutrient input is potentially more affordable to farmers and provide benefit in improving soil fertility because the organic material is often produced inside the farm in Africa. While the use of organic sources is more common, but is not enough to replenish the soil nutrients where we have soil with low fertility, because even that most farmers use crop residue manure as source for fertilizer, but the priority for this residue go to for livestock feed for livestock feed. But these sources of residue as organic, they have a low prices, but mostly they are produced near the household. And when we go away the household, the use of organic material decrease. Well, a lot of study in Africa, they have showed a gradient of organic fertilizer between the home field and outfield. In general, African farmer field is a gradual, the soil fertility decrease with increasing the distance from the homestead. The limit also for the use of organic under conservation agriculture, because the limited biomass production and the long dry season in some region of Africa. For example, here the example from South Africa, where it is a need for production for 1 ton of for the production for 1 ton of manure, we need at least a biomass production for feeding the cattle for 1 ton and 1 and 8 ton, almost 2 ton. The retention of crop residue and nutrients under conservation agriculture is the other pillar to take into account. The quantity of residue left in the field, the composition of the residue and its placement influence the decomposition rate in the soil. Now it is essential under conservation agriculture system to produce sufficient crop residue for mulching in the soil surface. The combination of high carbon nitrogen ratio plant residue and low soil nitrogen is expected to reduce nitrogen availability to plant, at least at the initial phases of crop growth. Also, the introduction of cancer has a significant impact on nutrient distribution and transformation in the soil by maintaining crop residue. The crop residue left in the soil decompose more slowly than those anchored in tillage system because of the limited contact between the soil microbe and the residue and the soil surface. However, the management of cover crops and also the residue is vital component. For that, some technical factors should be taken into account. For example, for the case of cereals, should be cut tillage-based system with optimal height. Also, for legumes, should be harvested by cutting. The plant should not be pulled up, and crop residue should be never mixed inside the soil. Also, for the best nutrient management of nutrients under conservation agriculture, IP9 and up now is developing decision support tool for the best nutrient management practices under conservation agriculture. One of them is Nutrient Expert, which is now validated for the case of wheat in Morocco, and still developed in some country also in Africa. And with this Nutrient Expert tool, we can get nutrient recommendation based on site-specific nutrient management, and by using the 4R nutrient stewardship based on the right source at the right rate at the right time at the right place. But even we have presented all this advantage of conservation agriculture with all this pillar. Limit be high and network exists. Conservation agriculture is unlikely to be adopted by farming in system where crop residue may have high value used than mulching. Also, some example like from crop residue in the Sahel and in North Africa may at the time fetch higher prices than grain and local market, mainly in drought season. On the other hand, soils that underwent severe degradation are likely unable to produce a new biomass during initial stage. And in conclusion, soil fertility improvement must go with the integration of all the components of conservation agriculture. This is only way yield can be improved, and without this, farmer will become discouraged. Inorganic fertilizer combined with organic fertilizer are indispensable to effective conservation agriculture and its adoption in Africa. Thank you very much. Please.
Thank you, Dr. Hakim BOULAL, for the presentation and for this very interesting topic about the plant nutrition management and conservation agriculture. So when you were talking, a lot of people were reacting, and this is very good because this is your topic is attracting and raising interest from the audience. I have a lot of questions, but I will select some of them for you.
Okay.
So I will start with one comment from Mr. Abdullah Abu Drer. I don't know if you know this person.
Yeah.
So Abdullah Abu Drer is commenting saying that reasoned nitrogen fertilization is required to avoid an imbalance in the mineralization of organic matter. So what do you think, Professor Hakim BOULAL?
What? Please, can you repeat the question?
So could we see it in the screen? It is in the screen.
Moment.
Go back to the StreamYard.
Okay.
And you will see.
Moment. Okay.
So reason nitrogen fertilization is required to avoid an imbalance in the mineralization of organic matter. So in the conservation of agriculture, of course.
Yeah, because you know that the mineralization also a function also and other factor because also the presence also and the residue on the soil. What I have talked. We need also a minimum of residue, but also about the type of residue, because the mineralization is not depending just on the presence of residue, but also in the type of residue. And in North Africa, if we consider in North Africa, the application of residue as a pillar of conservation agriculture is less than other regions. I know very good that we have less quantity of residue in the previous crop or nothing in the previous crop. Now in conservation agriculture in North Africa mainly, but the rotation between cropping like legumes crop fixing nitrogen with cereal give more positive results under conservation agriculture, what we have seen in different regions, and like the region, for example, and in Meknes, where is Dr. Boudre.
Okay, thank you, Hakim. So a question from Adnan Beniyash is saying, in the Mediterranean region, do we have some examples of cover crops that show good result in sodic soil?
Sincerely, we didn't yet tested rotation with some cover crop under sodic soil for conservation agriculture now in this North Africa, at least for North Africa region for the case of conservation agriculture.
So maybe you can answer this question from the same person, from Adnan Beniyash. The no-till of cereal crop in the Mediterranean region regarding the SOM sum, how many times you need to reach to the same level as in the native vegetation?
Therefore, we have variability of results in Mediterranean region. If you consider Mediterranean region, we consider, for example, North Africa. The soil organic matter can increase since the 30 years, but it's depending, because the soil organic matter increase with conservation agriculture, the increase is in the top soil. If, for example, with 3 years, we look for the 3 centimeter, you can look some improvement of soil organic matter. But when you go deep, for example, if we would like some in 5 or 7 centimeter, like the research that has been done by INRA in semi-arid area, you need at least 5 years for the improvement in soil organic matter in the top soil in North Africa region, in Mediterranean region.
Okay, thank you, Hakim. One question from Professor Al-Ammari Abdelali. He's thanking you for the presentation, and he said, according to the farm risk aversion and climate constraints of land availability and capital, do you think that conservation agriculture can be practiced by smallholder even we develop appropriate policy?
Yeah, what I have presented in my presentation, if we are talking with smallholder farmers for the adoption of conservation agriculture, we need the involvement, also the government policy. They need some subsidies or they need some political intervention, like what has been done, for example, in the Green Morocco plan, the aggregation of farmers. The aggregation of smallholder farmer in a group of farmer or cooperative or association can improve the adoption by smallholder farmer of conservation agriculture. If we know that the objective is to increase yield, at least some subsidize also the recruitment of smallholder farmers can be favorable for the practice of conservation agriculture here in North Africa or in Africa in general.
Okay, so we have another question from Mr. Abdullah Abu Drer. I don't know if you see the question. I just to mention that Mr. Abdullah Abu Drer is the Deputy Director of Research and Partnership in ENA. It's the
I know. I have seen the question. Yeah, the question is the application in the real condition is very difficult. I agree with you, Dr. Abu Drer. And you know that, for example, if we keep just the case of Morocco, Morocco started the first research in conservation agriculture since the 18th. It is almost 40 years. And until now, we are at least around 20,000 hectares for conservation agriculture with the intervention of association with the research. But first of all, I remember when we have started the adoption system of conservation agriculture in the initial year, the approach adopted was a linear approach to go from researcher to the extension agent to the farmer. And this linear approach showed a lot of limitation. For that, the linear approach changed to integration approach with farmers, extension, and researcher are integrated. And I think that if we can change the political, the system, the approach, we can go for the adoption. And I think now for the case of, for example, just the case for Al-Mutmir, now they have started a large program in conservation agriculture in Morocco. and with the involvement of Ministry of Agriculture, the involvement of the research institution, we can change the adoption of this system of government. But I have talked just in my talk about the three pillars: residue, also no tillage, also cover crop or rotation. If we have just rotation, no tillage, and we look how we can manage the residue, because the residue management is one of the constraints, the huge constraint of adoption here, due to the presence of livestock integrated the crop system. We need to find a solution for this small farmer, how they can keep residue on the field at least for some years. I know that, for example, I give you one example from Spain. The farmers, they have adopted conservation agriculture, for example, in Spain, because it was an intervention of European Union, and all the farmers, they practice, for example, conservation agriculture in sloping area in Andalusia, for example, they receive subsidies about that from European Union. And for that, we need to look how this three pillar of conservation agriculture can be totally applied in conservation agriculture here in our region, in Morocco or in North Africa.
Okay, we have a question from Mohammed Ouzin saying, we have to investigate, it's a comment, we have to investigate the effect of these practices, not only on chemical soil fertility, but also on biological soil fertility, to say mycorrhizal, fungi, bacteria, and so on. So is that still?
Yeah, still true. I agree with you. I have presented that in my presentation, because the biological activity and the activity of the fauna in the soil is very important for the improvement also the soil organic matter in the soil, and we need more research about that. There is a lack of research about the biological activity in the soil here in Africa. I think it is one of the important topics that we can look in the future.
Okay, so Professor Mohammed Boulif, again, someone you know, I think Professor Mohammed Boulif is saying conservation agriculture is okay with annual crops harvested for their upper ground parts. What do you recommend for root crops that need to disturb the soil to harvest the roots?
Good question, because I have talked about the rotation. Which type of previous crops or crop rotation can be applied in conservation agriculture? For the root crop, it is difficult to apply in conservation agriculture, but it's depending in the root crops. If we have some small root crops, that can be feasible, but if we have big root crop like sugar beet, for example, is difficult, because when we take off the sugar beet, we disturb a lot of soil. But still, some root crops, small crop applied for conservation agriculture, but it is also applicable, but not for all root crops.
Okay, thank you, Hakim. So a question from David Adubko. Given the difficult and problematic land tenure system in most African countries, how can the farmer derive the maximum benefit from conservation agriculture, given that it takes 2 or more 20 years to derive the maximum benefits?
Good question. I have presented that in my presentation. For smallholder, the farmer, it is difficult that they wait until 20 years. I agree with you. But in some management of conservation agriculture, by introducing the triple, we can see some improvements after 3-4 years. But the benefits in yield is depending also in the region, because in Africa we are going from semi-arid area or arid like the Sahel or some regions semi-arid in Morocco to sub-humid region. In this case, the application of conservation agriculture, what I said, need the involvement of some agricultural policy that can improve the income of smallholder farmer by subsidize or by association, for example. The development of agriculture smallholder farmer is very important.
Okay, thank you, Hakim. I just would like to remind the participants that even if they were not there at the beginning of the talk of Professor Hakim BOULAL, so this webinar was recorded, and you can watch it from the beginning at the end of this talk. At the end of the webinar today, you can still go to the ESAFE UM6P channel. You will find the talk by Professor Hakim BOULAL. So a question from Irana Kebede. So he's asking you, Hakim, for your presentation. He's asking, what do you recommend regarding the utilization of biological nitrogen fixation in conservation agriculture, especially in Africa, where cereal dominates the production system?
We know that in Africa the cereal are dominating. It's like here in North Africa, but a lot of experience I have seen in a lot of regions of Africa, they have introduced legume fixing nitrogen crop, and you know that cereal after cereal as monocropping is not just under conservation agriculture, but also under conventional tillage. Monocropping decrease the yield of the crop. For that, the diversification of the crop is necessary for all the cropping system. And I am sure that in Africa you find some biological fixing crop like I have seen in all the African countries.
Okay. So a question from Mohammed Luay Metougi, one of the researchers at the University Mohammed VI Polytechnic in Morocco. He's asking, do you think that the current crops from the genetic resources are adapted to conservation agriculture, or more effort should be made in plant breeding site to take full advantage of these systems and encourage their adoption?
Yeah, good question about that, because not just for conservation agriculture, we have seen that even crops are adapted to some systems. For example, just for the variety of cereal, for example, adapted to drought stress. You can see a lot of variability because the response of this variety, and I am sure that the adoption of some variety is necessary for this type of for the conservation agriculture system, and we need to assess the response not for the species, because the species of annual crops are there, like cereal, like legumes, but I am sure that the response of variety can give more results about the adaptation of variety of annual crops to conservation agriculture. We need more research about that also.
Okay. A question from Mr. Rashid Mrabit. I apologize for the professors or the people that I'm not given their titles because I don't know. So sorry for that. So I don't know if you are a professor or students or whoever, but sometimes from the
I know Dr. Rashid Mrabit from INRA.
Yeah, is okay. So yeah, I was doubting. This is why I'm apologizing. So Dr. Rashid Mrabit, he's asking, are you advising for advanced nutrient fertilizer management as a fourth pillar for conservation agricultural systems in order to regenerate agriculture in Africa?
Yeah. I am not the only that I would like to recommend nutrient fertilizer as a fourth pillar, because the recommendation of nutrient fertilizer management at fourth has been before recommended to be introduced at the fourth pillar for conservation agriculture. But because nutrient management is also used in other cropping system, and with the FAO, the FAO, because the FAO was leading this program of conservation agriculture. They would like to keep the third pillar, but nutrient management is one of the important topics that can be introduced in the management of conservation agriculture. And I would like to thank Dr. Rashid Barabit, because Dr. Rashid Barabit worked a lot about conservation agriculture here in Morocco, and a lot of publication come from him. Thank you very much, Dr. Rashid.
Okay, Hakim, we have now a question from one of our colleagues and partner from North Carolina State University, Professor Carlos Iglesias. He said, I have experience in root and tuber crops in Sub-Saharan Africa. With those crops, minimum tillage is quite difficult, given that farmers have to dig up the roots and disturb the soil. So what do you think? It's somehow related to the question from Professor Mohammed.
Yeah, I agree with him. What I have said as I have responded also to Dr. Bouli, the introduction of root and tuber crops in conservation agriculture system is difficult to maintain without disturbing the soil, mainly because you know the harvest of this type of crops is done by hand or by machine. For example, if you go to North Africa, it's done by machine, and it will be difficult to maintain. Can be a type of minimum tillage, as you said, but with a little bit disturbing in the road, just the distribution of the soil in the row where the crop is managed, because with the spacing in the field, we can take the space between the row without any disturbance. But in the road, we should to repeat the second crop in the same road. Can be one of the solution, but with minimum disturbance. We cannot just say we cannot disturb the soil. It's not possible.
So I have a lot of questions from some participants about the adoption of the conservation agriculture system by small farm holders. So there's a lot of question about this, the difficulties for them to adopt such a system. So if you can just summarize a little bit, what could be the guidelines that allow these small farmers to adopt or to use partially the conservation agriculture systems?
Yeah. Okay. For this type of smallholder farms, we are working in cropping system with the same cropping system. In my opinion, the adoption, also what I said before, is the groupment or association of smallholder farmers in the same cropping system. We have, for example, in North Africa, we have the wheat system, for example. And the involvement, also the government, for example, what I said, for the case of residue, the residue is used by the animals. This smallholder farmer, they cannot keep residue on the soil, and if the government can give for this smallholder an alternative for fodder or for plantation of fodder crops, it can be an alternative. Smallholder farmer alone cannot adopt conservation agriculture with the three pillars that I have presented, not even crop rotation, maintaining crop residue, but need political intervention, I say. And there are some examples in different parts of the world where the conservation agriculture has received some success.
Yes, thank you, Hakim. A question from Abdulatif Butagayut. He said anti-crop system, cereals, legumes, is very important. But what is the best modalities to find out maximum benefit for this type of anti-cropping?
Yeah, This type of intercropping is, for example, here or in most African region is applied legumes, cereal. One of the benefit of this application is when when this intercropping cereal, for example, legume is used as forage for animals, and we have positive result from conservation agriculture by the introduction cereal legumes as a forage. With the dependence from residue will be less if you introduce this type of intercropper. Even we know that also the legumes give more nitrogen to the cereal, and this interaction between no fixing and fixing nitrogen is very important for improving yield, but also for improving the soil fertility. But as forage can be a good solution also to decrease the pressure and the feed for residue.
Okay, thank you, Hakim. So now a question about pests and the soil. Someone from Mabuva consortium is asking, how can conservation agriculture can limit pests effects if it limits?
Yeah, it's just one report, because I said the introduction of rotation is one of the solution in conservation agriculture to limit the pest in conservation agriculture. Without rotation, you cannot limit the pest. Even some pests you can make some chemical product, but the rotation is the very important practice to limit the pest in conservation agriculture.
Okay, so there's another question in this within the same topic about the diseases. So is conservation agriculture can aggravate the diseases of the plants, and how can we overcome this problem?
No, we didn't see that conservation agriculture can aggravate the disease of the plants, but even in conventional tillage, we have several methods to deal with this type of disease. But
the link is made. The link is made to pathogens that survives on crop residues, and if they may aggravate the disease.
I didn't see that, but we can check in some research have been done about this type of pathogen in the soil has aggravated. But we didn't say that this type, if it exists, this type of pathogen, we have seen also some disease, root disease, also in conventional tillage in the same.
Okay, so we have one question from James Stewart Lahand. A student from the Fertilizer Science and Technology master degree. It's about the policies. Based on these constraints highlighted in adopting conservation agriculture, what policies and mechanisms to be used to break these barriers?
Yeah. The mechanism, what I say that, first of all, we need to adopt an integrated approach for the adoption of conservation agriculture, not a linear approach. Integrate between research, dissemination, and farmers. For the other policy is depending, because in the policy of each technology, of each cropping system for improvement, you need some government decision. Without government decision, it will be difficult to place this policy. And I have repeated a lot of one of the policy that can be applied, also the subsidized development of subsidies for example, for the drip bashir, for the input for farmers, or the development also the development of farmer under this conservation agriculture system.
Okay, so Hakim, here's another challenge that is raised by Peter Simon Weir. He said weed control is one of the key hindrances to conservation agriculture, especially where selective herbicides are still very costly. What are the alternative strategies to weed control under conservation agriculture?
Weed control is still one of the constraints of the adoption of conservation agriculture here in Africa. And if we know that herbicide in some region of Africa are costly, in other region no, but we can use some what I have presented, some intercropping system, some cropping system where the crop can shade the weed before his that the weed grow. It is one of the methods that can be used. Is the shadow of the weed before the emergence of the growth of. If not, we should to apply a herbicide. It is one of the contracts. I agree with everybody.
Okay, thank you, Hakim. So a new question about saline soils. So and saline agriculture or biosaline agriculture from Saad. He said that till can be recommended as an adequate technique for saline soils or saline agriculture.
Yeah, but for saline agriculture is like conservation agriculture. We should to plant the adopted species. It is one of the solutions. Yeah.
Okay, so it's still valid. Okay. So I just want to say to Jean, Mylène, and Marie, don't worry if you missed the talk by Professor Hakim. You can see it, of course, at the ESAFE YouTube channel. No problem. So thank you for your concern, Jean, Mylène, Marie. She is she comes very frequently to this webinar. This is why we have a question from Professor Ahmed Dahbani. He said, what kind of the state environment to incentivize the farmers in Morocco and in Africa to embrace mass adoption of conservation agriculture when the official strategy is largely market-based and lacking effectiveness?
Yeah, if we are looking just for the market, what they have presented, for example, the introduction of some species in the rotation of the crops in the large parts of Africa, it has been recommended the introduction of some species, mainly legume crops in conservation agriculture system. But by the end, the farmer, they didn't find the market, the adequate market for the grain to sell their legumes crops, and it was one of the contrary to the adoption of this type of rotation. For example, also, for example, in some country in South Africa, for example, is encouraged to plant by maize by the government, and some subsidized is giving to the plantation of maize. In North Africa, for example, like bread wheat here in Morocco, and I think the political should go to diversify the diversification of the crop and to adopt a good market for the crops adopted or introduced in the crop rotation, or also the main crop like cereal or legumes.
Okay. Again, thank you, Hakim. So now we are approaching the end of this webinar. So we will take like 2-3 questions, and then we can close the webinar. Thank you, Hakim. So a question from Basiru Sulaiman. Hello, Sulaiman. I know these students. You mentioned in your presentation, Hakim, that adequate fertilization is important in conservation agriculture. However, increased mineral nitrogen reduce mineralization by soil microbes. Will this be a problem, a challenge for conservation agriculture?
No, because we have showed also that the addition of nitrogen, we need just to find the adequate fertilization, nutrient management practice by introduction of nitrogen. But for that, it is not a problem for the case of conservation agriculture.
Okay, so there's a comment from Shijem Cesar. She's thanking you because she's. I'm sorry, I don't know if she or he. In her community, farmers face a problem of extension due to lack of qualified officials. She greatly thank you, Professor, for the information, since this is already applied knowledge. So just a comment. I wanted to show you this comment. So and then we have a question here from Irana Kibedi again. Do we have any principle or prerequisites to adopt conservation agriculture, or can we use conservation agriculture under all production systems?
For conservation agriculture, we should to see our objective. Why we would like to adopt conservation agriculture? Because I have presented that the implementation conservation agriculture, first of all, the first objective was to decrease land degradation and soil erosion. It was the first objective. Also, in some region, like semi-arid area, the introduction of conservation agriculture was the objective is to conserve water. And for all the region can be possible, but is depending on the impact of conservation agriculture and also of our objective. What will make conservation agriculture the difference against, for example, conservation tillage?
Okay, thank you. Just to let you know that one of the professors is thanking you for your talk. He commented on that one. I wanted to. It's Professor Ammari Abdelali and all the others, like Professor Gharous Mohammed, who just left the webinar. He thank you for the presentation also. So a question from Beta Thomas Kojera. He said, it's a very technical question, Hakim. Can plants grown in sacks and plastics containers, like urban gardening, be considered as conservation agriculture?
It's difficult to answer to that because the plastic inside of residue is not the same. You are using a material that need more than, I don't know, 50 years or 100 years to decompose. But in my opinion, I don't consider the introduction of plastic in system of conservation agriculture. That's for the plastic.
Okay, now I'm taking the last two questions. So I'll try to give you one which was not. I think that will, again, I'm sorry, I'm because there's a lot of questions there, and I'm selecting ones which were not asked before. Just give me 1 second, please. Yes, let's take this one from again, Dr. Rashid Mrabet. Most farming systems in Africa are pastoral and livestock dependent, and conservation agriculture system should be tailored to balance grain yields, biomass, livestock performance, and soil quality. What do you think, Si Hakim Boulal?
I think I have responded for this question by the introduction of conservation agriculture, because it is an integrated part with the we need to show this to find the balance between this livestock and also the grain production, and we need a lot of research about that also to see what is the minimum residue in some cropping system and agroecological region. In my opinion, we need to look the adoption of conservation agriculture not just for cropping system but also agroecological system, because it's depending also on the climate and also looking for a balance between livestock and grain production is one of the future for the option of conservation agriculture.
Okay, so the last question is from Abdelaziz Nilahian. Is a researcher in the University Mohammed VI Polytechnic in Morocco. He's thanking you for your presentation, Hakim, and he's asking what type of cover crops can be used to improve soil health. That's a really big question.
Yeah, it is a lot. You can use a lot of cover crop, just the crop that can maintain the crop residue and also to improve soil organic matter, because the cover crop is depending also of your region. Mediterranean region is not Sub-Sahara, is not also the southern Africa, but there is a lot of cover crop over the region of Africa that you can apply, because also is depending also on your target crop.
Okay. Okay. Even as I said, I will use only one question. I'm using this one also because it's a little bit technical. It's the last one. It's from S&F. I don't know if it is San Francisco or San Francis. I was not there at the beginning of the presentation. Could you please let us know what is the difference between conservation agriculture and permaculture approach?
I need to know, first of all, what is permaculture. I don't have any idea about permaculture.
Yes.
The first time I heard about this permaculture approach.
Okay, so okay, again, thank you on the name of all the participants, Professor Hakim BOULAL. I thank you on the name of many students, many professors, and people who were attended. So thank you again for this, for your presentation, for the talk, and for spending the time answering the questions. Okay, so like it was said at the beginning, Professor Hakim BOULAL is from the African Plant Nutrition Institute in Morocco, and he touched on the importance of conservation agriculture in the nutrient management as a nutrient management approach. So please, if you would like to see again this his talk, his presentation from the beginning, you can still see it on the ESAFE YouTube channel. You have just to go there, and you will have the full presentation available for you. So again, thank you, Hakim, for accepting the invitation, and for also answering all the questions by the audience. So I would like now to introduce our next speaker. Is Dr. Abdelaziz Harish. So Dr. Abdelaziz Harish is a professor at the University Mohammed VI Polytechnic in Morocco, and he will talk about quinoa and why quinoa as a potential of alternative crops in marginal environments. So his talk will be next Thursday of this week. So it will be at 2 p.m. GMT +1 time in Morocco. So you are very welcome to participate to this webinar by Professor Abdelaziz Harish. So before I close up the webinar, I would like also to point out for the students who are participating in this webinar that some of these nutrient management approaches, you can find them in as modules, also as educational programs in one of the master degrees developed by our school, Fertilizer Science and Technology. So we're talking about plant nutrition in this master degree and the problematic of soils and soil fertility, and of course the production of fertilizers industry. So if you would like to apply for this master degree, it's still time. You can go to send a request to ESAFE, to the email esaf@um6p.ma, or you can discuss with one of our coordinators, program coordinators, Mr. Ismail Ghorbal, through this WhatsApp phone number. Okay, thank you very much for your participation. Again, thank you, Professor Hakim BOULAL, for your nice presentation, and for also spending the time with us on the topic of conservation agriculture. Again, thanks to our colleagues from African Plant Nutrition Institute for supporting this webinar series in biotechnology and agriculture. Thank all of you for your participation, and I see you next Thursday at 2 p.m. time in Morocco for the talk of Professor Abdelaziz Harish. Thank you, Sidi Hakim.
Thank you very much, Dr. Yasri. Thank you for all the participants in this webinar, and I was very happy to participate with you today. Thank you. Thank you for all. Thank you.
We were glad to host you, Professor Hakim. Thank you. Everybody, and see you on Thursday.
Bye-bye. Bye-bye. Thank you.